Hello, everyone. So we're going to be talking about work and simple machines next. We've been talking about forces and motion, and now we're going to talk about some calculations involved with forces and motion and calculations involved with work. So yes, there's some math today. You all have a worksheet that you will be following along and filling out as we go along today. And then on the back, there's some calculations that you're going to try on your own. There's a couple on the bottom here that we're going to do together in the video. And then on the back, you're going to try these. It's really, once we get through it, it should be pretty straightforward. It's really just kind of substituting numbers. After that, I want you to go to a separate website so that you can do a little bit of reading, and I will be able to see how long you take at that website. So just make sure you're spending some time so that you really get a feel for work, what is involved with the scientific definition of work, because again, we have this definition that means something different in science. So I want you to get through that website, and then we'll start with simple machines next week. So let's go ahead and get started. We're going to take notes next week, so you don't have to worry about taking notes right now. So what is work? In science, work has a different meaning. It's using a force to move an object a distance. So the force and the motion of the object has to be in the same direction. So you're pushing a box, for example, forward. So you're doing work. But the two things that need to be met for work is that there has to be a force and it has to be moved a distance. So force and distance. Okay. So on your worksheet, you see that there's two conditions that need to be met: force and distance. We already know that the formula for force is mass times acceleration. So you can write that down too. Okay, so based on what we know about work, it needs to be a force over a distance. Which one do you think is work in this case? A teacher lecturing her class, is that work? Or a mouse pushing a cheese across the floor with its nose? If you said the mouse, you're right. So the mouse is using a force. Let me move the screen down so you can see this whole thing. Oops. The mouse is using a force to move the cheese a distance, and both the force and the motion are in the same direction. So again, here's our arrows that we've seen before, and we're going to talk about more next week. The arrows are both pointing in the same direction. The motion and the force are in the same direction. So let's go through these. You're going to answer which one do you think is work and which one do you think is not. A scientist delivers a speech to an audience. A bodybuilder lifts 350 pounds above his head. A mother carries her baby from room to room. A father pushes a baby in a carriage, and a woman carries a 20-kilogram grocery bag to her car. So some of these might be surprising. Again, scientists delivering a speech is not work. There's no movement there. A bodybuilder lifting a 350-pound barbell. Now there is motion there and there is force, so that is work. A mother carrying her baby from room to room. This is not considered work. Because she's carrying the baby, this is the same situation as the woman carrying the grocery bag. Because she's carrying it, there's no actual force involved. There is just, as we said before, the balanced force. The bag or the baby is not moving outside of the mother. They're moving with this woman, this mother. So there is no actual force that's pushing the baby or pushing the grocery bag in a direction. So neither of those are actually considered work. Whereas a father pushing a baby carriage, that is considered work. So this is a little confusing, so let's go through it step by step. The formula for work. Work is force times distance, as we said. We know that the unit of force is newtons. Make sure that you are following along on your worksheet this whole time. The formula for work is force times distance. The unit is for force is newtons. Okay. The unit for distance is meters. When we're talking about scientific things, we're talking about meters. The unit of work is newtons meters. So because we're multiplying force times distance, it's newtons times meters, it's nm newton meters. But it's also equal to 1 joule. So in order to shorten that, we can just say that the unit for work is a joule. Sometimes you'll see it as newton meter, but it's most often seen as a joule. So let's calculate together this first one. If a man pushes a concrete block 10 meters with a force of 20 newtons, how much work has he done? 200 joules. You just multiply. Easy peasy. Okay, so now we get into power. Power is the amount of work that's done over a period of time. So, and again, I put force times distance in here because work is our force times distance. So there's a lot of like continuation of calculations here. So we have work, which is force times distance, over the amount of time it took. Okay, and the unit of power is the watt. So, your second. How much power will it take to move a 10 kilogram mass at an acceleration of 2 meters per second? A distance of 10 meters in 5 seconds. Now, this sounds super confusing. You are not going to have a question like this on a test or anything. I just want to show you what it means to substitute in all these numbers. So we're going to go through this step by step. I want you to try it yourself. First, I have all of the formulas right on the top. The first one that we are going to talk about is force equals mass times acceleration, F equals ma right here. That's the first substitution you're going to do. Then we're going to move over to work. Work equals force times distance. And then we go to power. Power is work over time. So force equals mass times acceleration. You find the mass, you find the acceleration, calculate that out. Then you can substitute in force. And then once you figure out work, you can substitute in work to figure out power. So go ahead and try that out. So first step we do here, force equals mass times acceleration. 10 kilograms times 2 meters per second squared is 10 newtons. So that is our force. Substituting in force in our work formula, work is force, which is our 20 newtons, times 10 meters, which is our distance, is 200 joules. And then finally, our power. Power is work over time. 200 joules, which we just figured out over the 5 seconds, is 40 watts. Okay, so now you have a couple of, actually 3 total problems to do on the back of this sheet. Once you do that, let me know that you're done so that I can check them over. And then when you're done with that, you can move over to the other website that I have embedded and you can read it over. If you wanted to do the website first and then do the work on the sheet, that's fine, as long as you get both done today. Again, I'm going to be able to see how long you take on the other website, so I want you to really read it over and take some time. You have the whole period to finish this. So let me know if you have any questions.